Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora and today we are going to finish our exercise 10.2 from NCERT. We had already finished first 7 questions in the previous video. Now from question 8 to 13 we are going to finish in this video. This question says a quadrilateral ABCD is drawn to subscribe a circle. Right? The question says prove that AB plus CD is equal to AD plus BC. What we are given is a circle is given to us, circle with tangents AB, BC, CD and DA. What we have to prove is to prove that AB plus CD is equal to AD plus BC. So this is a quadrilateral which circumscribes the circle. Circumscribes means that this is made at the outer boundary of the circle, touching the circle at 4 given points, P, Q, R, S. So now here we start our proof. Proof is like you have learned the theorem that the length of tangents from an external point to a circle are equal. So you can see in the figure, first of all, like A is a point. From A, we have drawn two tangents, AP and AS. So length of these two tangents will be equal. Similarly, B is a point. From here, BP and BQ are two tangents from an external point. So the length of BP is equal to BQ. Right? Similarly, C. From C, we have tangents DR and CQ. From D, we have two tangents DR and DS. Now try to consider these 4 sides of quadrilateral as sets of tangents from these 4 points A, B, C, D. So we are applying the same theorem to these 4 points. Then we have AP is equal to AS. The reason being length of tangents from an external point are equal, right? So these two lengths AP is equal to AS. We can use the same reason for the next set, like BP is equal to BQ. Now the very important thing here, what you have to learn is, since you require the sum of these two sides equal to the sum of these two sides, so while writing these equal parts in the form of equation, you need to be very careful. What should be written below the set of tangents, like BP is equal to BQ. You can see that if AP and BP are added, what do you get? If AP and BP are added, you have to keep this in your mind. AP and BP are the fragments of or the sections of one length of the quadrilateral AB. So this we have when we are going to add these equations. So when we are adding AP and BP gets on the one side, you get AB as their sum, right? And on the side of AB, we have to keep CD here. So when we are writing about these CR and CQ, CR has to be on the same side where we have AP and BP. This is the only thing you have to keep in mind for this question. So check what I am doing. Next, for C point, CR is equal to CQ. But I am writing CR here and CQ here. Reason being the same for this. And for the last point D, we have DR is equal to DS. So I am writing DR here. DR is equal to DS. Now why? This is you could have written it on the other side also, because the parts are equal. They may be written as CQ is equal to CR. But in that case, when you will get the sum, this is not something that you will get. So keeping them in the same sides, like AP plus BP, I'm adding all the left hand side, the whole left hand side of this equation, CR plus DR. This is equal to AS plus BQ plus CQ plus DS. So now add these parts. AP plus BP gives you AB. CR plus DR gives you CD. Here, if you add these two, BQ plus CQ, what is BQ plus CQ is BC. And then you add this AS and DS. AS and DS add up to AD. Right? So if you need to get the same answer in one click, you need to be careful while writing the parts and making these equations. This is what we needed. AB plus CD is equal to BC plus AD. Right? Hence we have proved. The next question is, the question says x, y and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is 90 degree. So here we are given that, I'm writing it here. Given is circle C with center O and radius R in which xy, x dash, y dash and xy dash this and finally AB are tangents at point here xy P and x dash y dash is at Q and AB at C respectively. We are given these three tangents, right? Now, see, this question says what we have to prove that. To prove that angle AOB is 90 degrees. Right? Now, given that this, you're also given that xy is parallel to x dash y dash. Right? This is also very important. So now what happens? We had learned that whenever we have two tangents at diametrically opposite points. So now I'm writing the construction here. We have to join OC first. And then we have to prove, I'm giving you the outlay, we have to prove these two triangles congruent. Right? I'm writing the number of angles. 1, here it is 2, this is 3 and this is 4. First of all, we have to prove this triangle OPY congruent to OCY or OPA congruent to OCA. Then we have to prove OQB congruent to OCB. Right? So first we start proving these triangles congruent. In proof, in triangle OCA and triangle OPA. The first thing is, what are these things equal? Like, see, from the point A, AP and AC are two tangents. So the length of these two tangents become equal, right? Moreover, OP is equal to OC because both are the radii to the same circle. And then OA is equal to OA, which is common, right? So in triangle OCA and OPA, we have to write the parts of OC first. So OC is equal to OP. Why? Because they are radii to the same circle. Then we have AC is equal to AP. Why? Tangents from the same point. Tangents from an external point are equal. And the length of tangents from an external point are equal. Then the third thing is OA is equal to OA, which is common. Right? We can say that triangle OCA is congruent to triangle OPA by SSS congruence. Right? In the CPCT, we can write angle 1 is equal to angle 2. Now we have proved these two triangles congruent, so the corresponding parts are equal. Similarly, we can start with these two triangles. In triangle OQB and triangle OCB. First of all, we have OQ is equal to OC. Both are radii. Then we have BQ is equal to BC. They are tangents from an external point. Tangents from point B are equal. From an external point are equal in length. Right? And the third thing is OB is equal to OB, which is common. So we have these two triangles congruent. Triangle OQB. Be careful about the order of the name of the triangles. OQB, OCB. Triangle OCB, and this is also by SSS congruence. So after proving them congruent, we can get angle 3 as equal to angle 4 by CPCT. Corresponding parts of congruent triangles are equal. So now what we have got, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So now let this be first equation and let this be second equation. Now we have to see that line PQ is here. Line PQ is here, but this is not given that this is a straight line. What we need to prove is, like XY is, we know that XY is parallel to X dash Y dash. Right? Now we have to use this thing to prove that PQ is a straight line. How can we do that? How can we do that? See, this angle, this angle OP is what? OP is a radius to the tangent XY. OQ is the radius to the tangent X dash Y dash. Right? Right here. OP is perpendicular to XY and OQ is perpendicular to X dash Y dash. Radii are perpendicular at the point of contact. Radii are perpendicular at the point of contact. So now what happens? These are the two angles. Angle O, see angle OPY. Angle OPY, we can write here angle OPY plus angle OQY. OQY is again 180 degrees, right? And since what happens then? OPY and OQY both are 90 each, so their sum is 90 degree. That means angle POQ is a straight line. Straight line, because if we connect these two angles, and XY and X dash Y dash are two parallel tangents. So if we have two lines like this, these are the two angles at the opposite ends, and we have a common line joining this. So PQ becomes a straight line. Now what we can consider is, we can see that angle 1, 2, 3, 4. Angle 1 plus 2 plus 3 plus 4 is equal to 180 degrees. Why? We have proved that PQ is a straight line. PQ is a straight line. So all these angles are formed on the point O. Whatever you call linear pair, these are called linear angles. They are formed at a particular point on a straight line. What we can do, we can write angle 2 plus angle 2. Why? Because angle 1 is equal to angle 2. So I am replacing 1 by 2. Angle 3 is equal to angle 4. So I am writing angle 3 plus angle 3. I am replacing 4 by 3. So what do we get now? We get twice of angle 2 plus twice of angle 3 is 180 degrees. So we have twice of angle 2 plus angle 3 is 180 degree. That means angle 2 plus angle 3 is 90 degrees. What is angle 2 plus 3? Angle 2 plus 3 is angle BOA, which is 90 degrees. Right? So now we have proved that angle AOB is 90 degree, what we had to prove. Next question is, the angle between the two tangents drawn from an external point to a circle is supplementary. Let these be two tangents PA and PB with center O. we join these two radii, right? So what we are given is a circle C with center O and radius R, in which PA and PB are two tangents. Are two tangents. Now the question says we have to prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. So in this question, we have to prove that this angle between the two tangents is supplementary with the angle between these two lines, like these are the two radii. So these two angles add up to 180 degree. We have to prove that the angle between the two tangents drawn from an external point to a circle, angle between these two tangents supplementary to the angle subtended by the line segment joining the point of contact to the center, right? These are the two lines which are joining the point of contact to the center. That means OA and OB are two line segments which are joining the points of contact A and B at the center. We have to prove that angle APB plus angle AOB is 180 degree. To prove that angle APB plus angle AOB is 180 degrees. This is very basic question. What we can start with? These are the lines joining the point of contact to the center. Now what are they called? They are radius, right? So we start our proof here. OA is perpendicular to AP and similarly OB is perpendicular to AP, PB. So we have OA is perpendicular to AP and OB is perpendicular to PB. What is the reason? Now the line from the point of contact. Now the line from the point of contact to the center is perpendicular to the tangent, because these are nothing but radii. So radii at the point of contact are always perpendicular to the tangent. So this angle becomes 90 degree as well as this angle becomes 90 degree. So in quadrilateral OAPB, angle OAP plus angle APB plus angle PBO plus angle AOB. The sum of these four angles is 360 degrees. This is a quadrilateral. Angle sum property of a quadrilateral. Now OAP is 90 degrees. APB we do not know. And OBP or PBO is again 90 degrees plus angle AOB. This is 360. So what we can write here, APB plus angle AOB plus 180 degrees. This is 360 degrees. So the sum of angle APB and angle AOB is 180 degrees. 360 minus 180 is 180. Now the next question is, we have to prove that the parallelogram circumscribing a circle is a rhombus. This is A, B, C, D. Now we are given that ABCD is a parallelogram. ABCD is a parallelogram circumscribing circle C, right? What we have to do is let these point of contacts be P, Q, R, S. This is given that ABCD is a parallelogram. We have to prove that this is a rhombus. ABCD is a rhombus. For that we need to prove, see, a parallelogram already has opposite sides equal, but in rhombus we need to prove that the adjacent sides are also equal. So this is the target. You need to think and move in that approach. Now proof is, first of all we start with the theorem which gives that the length of tangents from an external point to a circle are equal. So we have 4 points A, B, C, D. Now we start with the 4 points A, B, C, D. We have pair of tangents from these 4 external points and the length of these tangents are equal. We start with A. Now AP is equal to AS. What is the reason? Length of tangents from an external point are equal, right? So AP is equal to AS. Then we start with P. We have BP is equal to BQ with the same reason. Similarly from C, CR. So now from C we have C. So now we have CR is equal to CQ, the same reason. And then finally from D, we have DR is equal to DS. Right? Now again, while writing these parts, we need to be very sure that the parts of one side of a polygon fall on the same side. Like you have to check AS and DS are on the same side, so that we add them, we get AD. Right? Now we are adding these 4 equations. Adding these 4 equations, we get AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. So what do we get? AP plus BP. AP and BP add up to AB. Then we have CR and DR. They add up to CD. AS, okay, we can add them first. BQ plus CQ. BQ and CQ add up to BC. And then AS and DS add up to AD. We had done this much in a question earlier also. So now what we can say that AB plus CD is equal to BC plus AD. So what is the relationship between them? See, AB and CD are already the opposite sides of a parallelogram and they are equal. So AB is equal to CD and BC is equal to AD. They are opposite sides of a parallelogram. So what we can do? We can write this as 2AB. AB plus CD becomes, AB is equal to CD. So AB plus AB becomes 2AB. Similarly, we have CD and AD. We can write this as 2AD. AD and BC are equal. And since they are equal, so we can write this as twice of AD. So we now have AB is equal to AD. See, AD, this is AD. This is AD and this is AB. Now what we have got? These are adjacent sides of a parallelogram. AB is equal to AD, but they are adjacent sides of a parallelogram. Adjacent sides of a parallelogram. And if they are equal, we can say that ABCD is a rhombus. ABCD is a rhombus. Because when the adjacent sides of a parallelogram are equal, it is called a rhombus. So next is, this is very interesting question. So in the beginning, we need to join these points and this also. Let this be D, E and F, right? So in this question we have to start with a triangle ABC is drawn to circumscribe a circle of radius 4 such that the segments BD and DC into which BC is divided by the point of contact D are of lengths 8 and 6 respectively. Find the sides AB and AC. Radii are 4. These are 4. Right? Now one more thing. If CD is 6, CD is a tangent from an external point C. So tangents are equal from an external point. So CF also becomes a tangent. This becomes 6. BD is a tangent from B. So is BE. So I write BE as 8. So now you can see that we have got these two fragments of AC and AB as well. Now AF and AE are two tangents from point A which are not known to us. So I'm assuming these parts to be equal as X, right? And these are all perpendicular sides. This is what we can make out in initial stages. Now we start with the question. We have to find AB and AC. So the objective of this question is to find X only because these parts are now known to us. CF and BE we have already found. So what we can do to find X? You have to keep your approach like you have to find the area to find X initially, right? AB and AC. So X is the target. Now what we start with, area of triangle AOC. You can mark these things. See, these are the whole triangle ABC can be broken down into these three triangles AOC, BOC and AOB. So I'm trying to find the area by these three parts. Area of triangle AOC plus area of triangle BOC plus area of triangle AOB, right? AOC is half base into height, half AC into OF plus half BC into OD plus half AB into OE, right? So I have applied the formula of area of triangle half base into height. You can see half is common, right? OF, AC is what? AC is X plus 6 and OF is 4. This is radius. And then we have half BC. BC is 8 plus 6, 14 multiplied by the radius which is 4. So BC is 14 multiplied by the radius 4 added to AB. AB is X plus 8 multiplied by radius which is 4. Now you can see that 4 is also common to this. We can take out 4. 2 is also common in denominator. So we are left with X plus 6 plus 14 plus X plus 8. So this is 2 times X plus X, in bracket we have 2X plus 14 plus 6, 20, 28. Again we have 2 common, which is 4x plus 14. So this is the area of triangle. This is what? This is the sum of areas of these three triangles which add up to area of triangle. Area of triangle ABC. Right? Now we have got this area of triangle ABC by using the sum of these three smaller triangles. One more method is there. Area of triangle ABC can be found by using Heron's formula, right? Now by Heron's formula, sum of three sides is x plus 6 plus 14 plus x plus 8. This is x plus 6 AC, BC is 14 and AB is x plus 8. So this is 2x plus 28, right? 2 can be taken out common, which is x plus 14. So s becomes 2s is this. So s becomes 2 get divided. S is x plus 14. Now area of triangle ABC is equal to this S. You can use this formula S minus A, S minus B, S minus C. So now we have, what is S here? X plus 14. In this triangle we have x plus 14 minus A. A is what? The first side is x minus 6. So since we are subtracting, I am changing the signs. Signs of both the values get reversed. Minus x minus 6. In multiplication we have s minus b. S is x plus 14 minus b. B is 14. Then x plus 14 minus c. This is minus x minus 8. Right? So now we can calculate this as, this is x plus 14 multiplied by x minus x. This is 14 minus 6 is 8. This is x. And this is 14 minus 8 is 6. Right? So now we have got the area of triangle in these terms. Don't get into calculations here because it will become ambiguous. We can simply do that. We can equate this area to the area we had found earlier. This. Let this be equation 1 and let this be equation 2. So from 1 and 2, 4 times x plus 14 is equal to square root of 8 6 of 48 x, in bracket we have x plus 14. Now squaring both sides. Squaring both sides, we get square of this whole term becomes square of 4, which is 16. So this becomes x plus 14 whole square, and here this square root gets reduced. This is 48x into x plus 14. Now we can reduce this bracket. We have square here and single bracket here. One is reduced. So now we have 16 times x plus 14 is equal to 48x. Open this now. This becomes 16x, and 16 into 14 is 4 6 are 64 and 16 4 224. 224 is 48x. So we have 48x minus 16x. 48x minus 16x is 224. This is 8 minus 6 is 2. 32x is 224. So x becomes, solving x here, 224 by 32. 4 8s are 4, 5s are 20, 8 1s are 8 7s are. So value of x comes out to be 7 centimeter. Right? Now we have got x. That was the ultimate requirement. Finally, we have to write the values of AB and AC. Now what is AB? AB is, we can write here, AB, if this is 7 and this is 7, AB becomes, AB is 8 plus 7, that is 15 centimeter. And what is AC? AC becomes 6 plus 7, that is 13 centimeter. Right? So the final answers are, this is 15 centimeter and AC is 13 centimeter. Right? The last question is, prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Right? So we have to make a circle, and circumscribing a circle, we have to make a quadrilateral here. A, B, C, D. The opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Now you have to join this. right? What we have to prove here. So now this is a figure that we have got from the question. Here we have to prove that given is circle in which O is the center and quadrilateral ABCD circumscribes the circle, right? So here we have to make some constructions. First of all, what we have to prove is to prove that these opposite sides means AB and CD. Let us take one pair at a time. AB and CD, when they are subtending these two angles at the center, that means angle AOB plus angle COD is 180. Angle AOB, sum of these two angles is 180 degree, right? The angles subtended by the opposite sides are supplementary. Similarly, this whole angle and this whole angle adds up to 180. Angle BOC plus angle AOD is 180 degree. Now what I am doing is I am joining these points of contact. Let this be, start from here, P, Q, this be R and this be S. I am marking these angles as 1, 2, 3, 4, 5, 6, 7, 8. Now this is a basic question but seems to be difficult. So I'm starting proof here. What we have to do is we have to prove these triangles congruent. Like from B, I'm starting from here. Triangle AOP, triangle AOP and triangle AOS and triangle AOS. How can we do that? First of all, AS is equal to AP. AS is equal to AP, tangents from A. Tangents from same point A are equal in length. Then we have OA is equal to OA, right? And then OS is equal to OP. OP is equal to OS. They are radii, right? So in this triangle, these two triangles are congruent by SSS congruence. Triangle AOP is congruent to triangle AOS by SSS congruence. So I'm not doing all the four parts here. I'm just explaining you that this triangle is congruent to this triangle. So we get angle 1 is equal to angle 8 as CPCT. Now what we have to do is you have to prove these two triangles congruent. So I'm writing here triangle. You can use the same three sides to prove these two triangles congruent. Triangle BOP is congruent to triangle BOQ. So what do we get? Angle 2 is equal to angle 3. But again, you have to write them in a proper order so that we get these two angles on the same side along with these. So 1 is to be like write 2 here and 3 here. This is CPCT. Similarly, triangle COQ is congruent to triangle COQ by SSS. So now triangle COQ is congruent to triangle COR. So we have angle 4 is equal to angle 5. 1 is equal to 8 here, 2 is equal to 3, 4 is equal to 5. And finally, triangle ROD is congruent to triangle SOD by SSS congruence. So finally we have angle 6 is equal to angle 7. Now these are the four equations, 1, 2, 3 and 4. Now we can add all these four angles. We know that these four angles are about a point O. So we have angle 1 plus angle 2 plus angle 3 plus angle 4, 5, 6, 7. I'm erasing this because space is less. 7 plus angle 8. All these angles add up to 360 because this is a complete angle around the point O. So now we have to be very careful. We have to write like 1 is equal to 8. So at the place of 8, I am writing 1. I am taking this here. So I have used this, right? Now 1 and 2. Now 2 is equal to what? Angle 2 is equal to angle 3. So at the place of 3, I am writing angle 2, right? Now, which angle is equal to? 4 is equal to 5. So I am eliminating 4. I am writing it as 5, right? You will see why I am doing this. Right, 5. And then I am 6 is equal to 7. I am eliminating 7 and I am writing it as, this is already 6 and I am writing this as 6. We have got the same angles. The only thing is, at the place of 8, I have written 1. At the place of 3, I am writing 2. I am just writing these equal parts and eliminating those which are not required right now. So what happens? This is twice of angle 1 plus twice of angle 2 plus twice of angle 5 plus twice of angle 6 is 360 degrees. So we have 2 common, right? Angle 1 plus angle 2. We can club these. And angle 5 plus angle 6. This is equal to 360 degrees. So 2 can go and divide it here. Angle 1 plus angle 2 is angle AOB. 5 plus 6 is angle COD, which is 180 degrees. Right? So we have got this. I have now, you must understand that I have eliminated those parts which were not required. My objective was to get angle AOB along with angle COD. So 1, 2, 5 and 6, they give us those two angles. So I have just written those equal parts, 3 being replaced by 2, 4 being replaced by 5, 7 being replaced by 6 and 8 being replaced by 1. So they become twice of these respective angles. I get angle AOB plus COD 180. So by the angle sum property, like angle AOB plus COD is 180. If you add these four angles respectively, then the sum of these two angles also come out to be 180 degree. So I hope this is clear to now. Similarly, you can write this by taking the sum of these four angles is 360 and these angles add up to 180. So the sum of these two angles is also 180. Right? So I hope this is clear to you now. I hope you liked watching this video. Please like, subscribe and share it with your friends. Thank you.